Example calculations using Newton's equations C equals lambda nu. If a radio wave has a frequency of 97.9 megahertz and a wavelength of 3.06 meters, how fast in meters per second does it travel from the radio station to your receiver? In solving calculations dealing with light, there are some variables that you can discover. So first we have frequency. Frequency is represented with the Greek letter nu. In this case, the frequency is 97.9 megahertz. In most calculations, we need to use the regular or standard unit instead of mega. Now, you have already learned your metric train tracks, so now you can do a simpler calculation. So we will take 97.9, and remember that mega is 6 away from standard units, so we will multiply 97.9 times 10 to the 6th, and this will give us regular hertz. The wavelength in this problem is 3.06 meters. Wavelength is represented with lambda, 3.06 meters. The speed is what we're looking for, so that could be x. We can also substitute it into the equation. C equals lambda nu, so we'll put lambda first, 3.06 meters, times the frequency, which we converted, 97.9 times 10 to the 6th per second. Multiply those things with your calculator. 3.06 multiply sign, 9 EE 6. Enter. You should get an answer that's very close to 3 times 10 to the 8th meters per second. How do the speeds of microwaves, yellow light, and X-rays compare? Well, they are all types of light, just like the red light from a helium neon laser and the radio waves that come from the radio station. They are all the same. 3 times 10 to the 8th meters per second is exactly the same as 3 times 10 to the 17th nanometers per second. These values are very important and should be added to the chart of your variables that we filled in, okay, for the C, the lambda, and the nu. How are wavelength and frequency related mathematically? They are related inversely. If a radio wave has a frequency of 106.5 megahertz, what is the wavelength of this light in nanometers? In this equation or problem, we notice that frequency is given, and we're asked to find the wavelength, but the speed of light is not given. Well, from the equation, we have C equals something, lambda must equal something, and so must nu. Okay. So the frequency is 106.5 megahertz. Frequency is nu, 106.5 megahertz. Usually we can't use mega, so we will convert it. Okay. So if we look at our metric train tracks or any other way you remember your metric conversions, we see that mega is 6 steps away from the standard units. So we can write in times 10 to the 6th because mega is large, and that is hertz. Okay. We're asked to find the wavelength. Wavelength is lambda. That is our unknown. And C is not given. Well, C is the speed of light, and the speed of light is constant. Since the question says, what is the wavelength in nanometers, we'll choose the speed of light that has nanometers in it. So that is 3 times 10 to the 17th nanometers per second. So now we can set up the equation, okay, which is this one. C equals lambda nu. C is 3 times 10 to the 17th nanometers per second. Okay, and that is equal to lambda, or our x, times the frequency, okay, 106.5 times 10 to the 6th per second. And then to solve that, we will divide each side, both sides, by 106.5 times 10, whoops, forgot my 10, times 10 to the 6th per second. Okay, so those will cancel out, okay, from there, and divide it here. Okay, so we're going to divide these two. Okay. And then after you put that into your calculator, you should get about 2.8 times 10 to the 9th nanometers. So most of the time when you solve equations solve problems using Newton's equation, you will be solving for lambda or nu. The speed of light is a constant, so you can look that up, and you can use 3 times 10 to the 17th if you have nanometers in the problem, or you could use 3 times 10 to the 8th if you have meters in the problem. Happy calculating!